Jai Hind everyone. I am Achintya Pandey as a assistant professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Right. So today I am going to present my topic clustering and its various type in the subject data analytics. Right. So what is clustering? How many clustering we generally do using machine learning and all? Here we will see, right? So the objective is to explore basically clustering and its various types. Clustering is basically, see, there are various data points, right? So we get how we get the similarity among the data points. So there are so many ways to get the similarity among of the data points. So we group based on the similarities, right? So there are say Euclidean distances, or there are kind of factors by which we find similarity and make as a group, so that it could distinguish from another set of data point which is in another different group. Okay, so the process of examining a collection of points and grouping them into cluster according to some distance measures, right? It is not always required the distance, or it could be some other determining factor, right? So in machine learning, clustering is basically the process in which we create groups in a data like customer, products, employee, text document in such a way that objects falling into one group exhibit many similar property with each other and are different from objects that fall in the other group that got created during that process. So the goal basically is the points in the same cluster have a small distance from one another, while points in different cluster are at large distance from one another. For example, say we have the so many data points, right? So what we do if there are points, so how we make the cluster? Suppose we get 2 points just for the observation, and rest will be determining points. How we determine that it will be in one cluster and some points will be in another cluster. So we get the distances from, say, suppose these are the determining point and these all are some observing point. So we get the distance from this point to this point and another from this point to this point, from this point to this point, from this point to this point, using Euclidean distance, like we get the distance from x2 minus x1 ka whole square, right? These are the coordinates, plus y2 minus y1 ka r whole square, right? So these are some points and we could get the distances, right? So if the distance is minimum out of these other points, then we could make cluster, right? Like we get some distance if we observe these points, so we calculate this one. Similarly with this one, so which distance is minimum we put into one cluster, right? So by that way we make cluster, or there could be some other determining factor by which we could find the similarities. So the objective is to find the similarity among the data points, so that we could make a group, right? And that group become the cluster, right? So the main issues of this clustering would be data is very large, high dimensional data space, so many features could be there. Data space is not Euclidean, that is NLP problem, right? So we have just drawn some data points, right? And we try to make some, kind of group which has been shown with a different color, like green color, blue color, orange and all, right? So we by that way we find the cluster. So here we could see that there are 3 cluster which has been shown in 3 different color, right? So we in this point, okay, estimated number cluster is been shown with the blue, green and red color, right? Okay, so clustering algorithm. So what are the algorithm? What are the steps which follow just to do that? So this algorithm takes the data and using some sort of similarity matrix, they form this group. Later, this group can be used in various business processes like information retrieval, pattern recognition, image processing, data compression, bioinformatics, etc. So we need to attain two major goals. One, a similarity between one data point with another, and two, a distinction of those similar data point with other point which most certainly or heuristically differ from those points, right? The cluster that we need should not only be able to distinguish data point, but also they should be inclusive. So again, the point is how we are going to identify the similarities, right? And based on that similarity, we distinguish the groups and we make the clusters, right? So a distance metric helps a lot, but the cluster shape is often limited to being a symmetric shape, and many important data point get excluded. This problem too needs to be taken care of, right? So using Euclidean distance, this problem occurs and the problem need to be taken care of. Okay. So the different type of clustering which we use are basically connectivity based clustering, which is also known as hierarchical clustering, centroid based clustering, sometimes known as partitioning method, distribution based clustering, density based clustering, it is also called model based method, fifth, fuzzy clustering, and sixth, constraint based clustering, which is also known as supervised cluster. So these all are some most useful or general types of clustering which we could make that, right? So we will see one by one these all six clustering how we do. So let's see first hierarchical based clustering, or you can say it connectivity based clustering, right? So you know hierarchy means just like tree, like we follow one node, one big node divided into separate node and so, right? So you can say sometimes it's a top to bottom, top down approach, right? And just to creating bigger cluster, we could move from bottom to top approach, right? So hierarchical clustering is basically, it is a method of unsupervised learning, machine learning clustering, where it begins with a predefined top to bottom hierarchy of cluster. It then proceeds to perform a decomposition, right? Problem is divided into subproblem and this. So it then proceeds to perform a decomposition of the data object based on the hierarchy, hence obtaining the cluster, right? So here we, what we do, basically it is a method of hierarchical, I mean decomposition, right? We make the hierarchy by decomposing top to bottom, right? So this method follow two approaches based on the direction of progress, whether it is top down, or it is bottom up flow of creating cluster, right? So the approach which we use, the name of these approach are called some divisive approach, and bottom up approach is called agglomerative approach respectively. So what is divisive approach? The divisive approach follow a top down approach, okay? So all the data point belong to one large cluster and try to divide the data into similar group based on the termination logic, or you can say a point beyond which there will be no further division of data points. This termination logic can be based on the minimum sum of square of error, right? So this is the point, minimum sum of square of error inside a cluster, or you can say for a categorical data, the metric can be Gini coefficient inside a cluster, right? So hence iteratively we are splitting the data which was once grouped as a single large cluster to n number of smaller cluster to which the data points now belong, right? So taken into account that algorithm, this algorithm, it is highly rigid when splitting into the cluster, meaning once the clustering is done inside a loop, there is no way that the task can be undone. We can undo the task, right? Once it is done, we could it is done, right? We can't undo the task, right? For example, here we can see that top down approach, or you can say divisive approaches, like we have this node and the data value are here are p, q, r, s, t. So we have divided we can see the hierarchy, right? Just like as a tree structure, in tree we have a node which is divided into two node, and every node, and then again this I mean descendant node is further divided into descendant, say here two node, and are like just like as a, you can say that this is been divided into as a binary tree, right? So every node has at most two child, right? So here we can see. So this from top to bottom, it is called divisive approach. And again, if we synthesize all those like this, two node become one single group, or you can say cluster. Similarly here we could make this one. So from bottom to top, if we progress, then this is called agglomerative approach. Okay. So agglomerative approach is quite and contrary to divisive approach, that is top to bottom. All the n data point are considered to be a single member of n cluster that the data is comprised into, right? So we iteratively combine these numerous n cluster into fewer cluster. Let's say k cluster, and hence assign the data point to each of these cluster accordingly. So this approach is a bottom one, and also use a termination logic in combining the cluster. So the logic can be number based criteria, or you can say it is called no more cluster beyond this point, or a distance criteria. Cluster should not be too far apart to be merged, right? So these all are the criteria, like number based criteria, distance criteria, variation criteria, in which we increase in variance of the cluster being merged should not exceed a threshold, right? So that method is called Ward method. So this is the criteria just to form agglomerative, or you can say bottom to top approach. Okay. Next clustering is centroid based clustering. So what we do in centroid based clustering, it is considered one of the simplest clustering algorithm and the most effective way of creating cluster and assigning data points to them. Okay. The intention this is that a cluster is characterized and represented by a central vector and data point that are close to these vectors are assigned to the respective cluster. These group of clustering method iteratively, here the point is iteratively must be do repeated measures the distance between the cluster and the characteristic centroid using various distance metrics. So these could be either Euclidean distance, like under root x2 minus x1 ka whole square plus y2 minus y1 ka whole square, or Manhattan distance, or Minkowski distance, right? So the major setback here is that we should either intuitively or scientifically define the number of cluster k to begin the iteration of any clustering machine learning algorithm to start assigning the data points. Okay. So these are the criteria. Okay. Like here we see these there has been shown different data point, and based on the Euclidean distance or so called Manhattan distance or Minkowski distance, we form different cluster. Here we three different colors. So this is the making different groups been there based on some distance matrix. Okay. So despite the flaw, centroid based clustering has proven its worth over hierarchical clustering when working with the large data sets. So it is better over the hierarchy based clustering. So also owing its simplicity in implementation and also interpretation, these algorithms have wide application area. For example, in market segmentation, customer segmentation, text retrieval, image segmentation, centroid based clustering is more useful or more significant, right? Next type of clustering is density based clustering. So in density based clustering, let's see, the previous two methods are dependent on distance, that is similarity or proximity. The very definition of a cluster is based on this matrix, but in density based clustering method take density into consideration instead of distance. So cluster are considered the densest region in data space, separated by region of lower object density, and it is defined as a maximal set of connected point, right? So lower object density will be the maximal set of connected point. So when performing most of the clustering, we take two major assumptions. One, the data is devoid of any noise, and two, the shape of the cluster so formed is purely geometrical, that is circular or elliptical. Okay. So here we can see the difference. This is the example of data points have been shown and making cluster using the density based clustering. Sometimes it is also called model based methods. Okay, so in density based clustering, data always has some extent of inconsistency, that is noise, which cannot be ignored. So must not limit ourselves to a fixed attribute shape. It is desirable to have arbitrary shape, to not ignore any data points. So these are the area where density based algorithm have proven their worth. The density based algorithm can get us cluster with arbitrary shape, cluster without limitation in cluster sizes, cluster that contain the maximum level of homogeneity by ensuring the same level of density within it, right? You can ignore homogeneity by ensuring the same level of density within, and also these clusters are inclusive of outliers, or you can say noisy data. So next category of clustering is distribution based clustering. So in distribution based clustering, there is a family of clustering algorithm that consider a totally different metric, that is called probability. So here probability is used. You have seen or heard the name of probability distribution, right? So distribution based clustering creates and groups data point based on their likelihood of belongingness to the same probability distribution, like Gaussian, binomial, etc. So the distribution model of clustering are most closely related to statistics, as it is very closely related to the way how data set are generated and arranged using random sampling principle. So the sampling principle are used, that is to fetch data point from one form of distribution. Cluster can then be easily defined as objects that are most likely to belong to the same distribution, right? So here we can see different clusters using the distribution based clustering, right? So okay. So a major drawback of density and boundary based approaches is specifying the cluster a priori to some of the algorithm, mostly the definition of the shape of the cluster for most of the algorithm. So there is at least one tuning or hyperparameter which needs to be selected, and not only that is trivial, but also any inconsistency that would lead to unwanted result. So distribution based clustering has a vital advantage over that these clustering methods work well only with synthetic or simulated data, or with data where most of the data points most certainly belong to a predefined distribution. If not, the result will overfit, right? So now next clustering we have is fuzzy clustering. So the general idea about clustering revolve around assigning data points to mutually exclusive clusters. How we get the mutually exclusive cluster, meaning a data point always reside uniquely inside a cluster and cannot belong to more than one cluster. Okay, so a fuzzy clustering method changes this paradigm by assigning a data point to multiple cluster with a data point to a multiple cluster with a quantified degree of belongingness metric, like we see in the fuzzy logic also. So the data points that are in proximity of the center of a cluster may also belong in the cluster that is at higher degree than points in the edge of a cluster. So the possibility of which an element belong to a given cluster is measured by the membership coefficient that vary from 0 to 1. So 0 to 1 like 0.1, 0.5, 0.6. So depending on the degree of membership coefficient, we get the distinction and make the cluster, right? So fuzzy clustering can be used with a data set where the variable have a high level of overlap. It is strongly preferred algorithm for image segmentation, especially in informatics, where identifying overlap gen codes makes it difficult for generic clustering algorithm to differentiate between the image pixels, and they fail to perform proper clustering. Okay. Next clustering is constraint based, that is supervised clustering. So in constraint way, that is supervised clustering is based on the approach that the data can be divided into an optimal number of unknown group, right? Data could be divided into unknown group, optical number of unknown group. Okay, so optical number of unknown groups, right? And the underlying stages of all the clustering algorithm are to find these hidden patterns. What are the patterns? based on the similarity, and similarity without any intervention of predefined condition. However, in certain business scenario, we might be required to partition the data based on a certain constraint. So this is where a supervised version of clustering machine learning technique come into play, right? So a constraint is defined as the desired property of the clustering result or a user expectation on the cluster. So form this can be in terms of a fixed number of cluster or the cluster size or important dimension, that is different variable that are required for the clustering process. So this is the example. These data point been shown and the dots are been shown. So clustering analysis, less parameters but more user desired constraint. For example, an ATM allocation problem, right? So usually tree based classification on machine learning algorithm like decision trees, random forest, gradient boosting are made used to attain constraint based clustering. So a tree is constructed by splitting without the interference of the constraint or clustering label. Then the leaf nodes of the tree are combined to form the cluster while incorporating the constraint and using suitable algorithm. So here at last what we basically being done in clustering, we get the similarity. How we find the similarity? Either by distance or density or could be these determining factor by which we find the similarity and make the cluster out of that, right? So thank you everyone.